Good morning, students. In the today's session, we'll start learning about RSA algorithm. This RSA, the full form for the RSA is reverse Shamir and algorithm. It is a widely used public key crypto system that enables the secure communication and digital signature over the insecure channel. Let me see here the main theme of this RSA algorithm is it is one of the most popular and secure asymmetric encryption algorithms, and it was introduced by Ron Rivers, Shamir, and Leonard Alderman in 1977. And the main theme of this RSA algorithm is for the transmission of data between the two systems. It is mainly used for the encryption as well as decryption. What are the main key components for the RSA algorithm? See, here whenever you are working with the RSA algorithm, we have mainly public key as well as the private key. What is a public key and what is a private key here? Whenever you are working with the public key, it is mainly having two main components. One is a modulus. It was symbol with N, and the other component is exponent. Okay, it was symbol with A. And the modulus is the product of two large prime numbers, that making it changing to the factors. Now see here, whenever if you are working with a private key, it consisting of 2 parts. One is a modulus and the other one is the exponent, which is derived from the primes used to generate the public key. What is this key exchange here? Whenever you are working with this RSA algorithm, the public key can be shared by openly and the private key is kept secret. Mainly the public key is mainly used for encrypting a message, and the private key is mainly used for decrypting a message. Whenever you are working with this RSA algorithm, we have the public key as well as the private key. The public key main theme is it was shared by anyone, and the public key main theme is to encrypt a message, and the private key is can be used for decrypting a message. Now we'll learn about what is the encryption as well as decryption. What is encryption? Encryption is a process which involves converting the plain text into cipher text. What is meant by decryption? It is going to convert the cipher text into original plain text. But for the conversion of this cipher text into plain text, we are going to use the public key components. As in the previous slide I have explained, in the public key components, we have N and E. N is the exponent, okay, and modulus, okay. And next we have the plain text is converted into ciphertext, which is calculated with the formula of C by equals of P power E mod N. And what is the theme of decryption? This decryption is performed by using the recipient public key. In this recipient public key, here recipient private key. In the private key components, we have the exponent modulus as well as the exponent. These are the two variables are there. And in the decryption, we are going to convert the ciphertext into plain text using the formula P by EP of 3C power D modulus N. And next, what is meant by a key strength? When you are learning about this RSA algorithm, you should learn the following concepts, like what is a key strength, what is a digital signature, and what are the applications. What is a key strength? See here, the security of the RSA algorithm, it is mainly released on the difficulty of factorizing the large 2 prime numbers. Here we have to take the large 2 prime numbers and we have to take it to 2 prime factors, and the larger the key size, the more secure the encryption. What is meant by this digital signature? This RSA algorithm is mainly used for digital signature, which is going to provide a way to authenticate the sender of a message and verify the integrity of the message. To create this digital signature, the sender uses a private key to sign a hash of the message. The recipient can then use the sender's public key to verify the signature. Whenever you are working with a digital signature, here the main point is to create a digital signature, the sender uses a public key. The sender uses a public key to sign a hash of the message, and the recipient can use a public key to verify the signature of the message. And what are the applications where this RSA is widely used? This the RSA algorithm is widely used in secure communication protocols, such as HTTP security, HTTPS for secure web browsing, and SSH for secure shell communication, and PGP for petty group privacy. And it is mainly used for the email encryption. And it is also employed in digital certificates, digital signatures, and also the various secure communication scenarios. And what are the challenges and considerations which are there for the RSA algorithms? And the RSA operations are especially the key generation. It can be computationally intensive, especially with larger key sizes. And next, as computing power increases, the larger the sizes are recommended to maintain the security. And here we have the quantum computing poses a potential threat to RSA, as it has a potential to efficiently factorize the large numbers and by making the RSA secure. And in summary, the RSA is a fundamental public key crypto system, and with applications, it is mainly used in with the secure communication as well as for the digital signatures. And its security relies on the difficulty of factoring the large two products into two large prime numbers. First, we have to take the two large prime numbers and we have to deduct with minus. For example, if I take 17 and 27, okay, we have to subtract the 17 and 27, 17 by 1 and 27 by 1, we minus 1, we have to take, okay. Then we have to implement the public key formula. Then we have to implement the private key formula. And for the encryption, what is meant by encryption? In the encryption, the plain text is converted into ciphertext by using the formula C is equals to M power E mod N. And M is a modulus and E is a exponent. And see, in the decryption, what is happening here? The ciphertext is converted into the plain text. That is, M is equals to C power D mod N. Like this, we are going to calculate the encryption and decryption. That means the for the transmission of data using the RSA algorithm, we are going to calculate. Now see here in this example, I have taken the two prime numbers. Here we have to take the, whenever if you are working with the RSA algorithm, we should take the two large prime numbers, that is 17 and 11. And now what is our theme? We have to multiply the 17 with 11. Then we'll get the 187. Okay. Then we have to calculate the order of n, that is p minus 1 as well as q minus 1, that is 16 into 10. Okay. Now here, this order of n is equals to 160. It is less than order of n. We are going to choose the exponent value as 7 we can take. Okay. And the correct value for this is here. Here we have 16 plus 17 plus 7, 23 will get. Okay. Here the 23 and 7. Determine D such that D modulus 160. D is less than 60. Then the correct value for the D value is 23. Now we should work with the, now what is our work? Now the resulting public keys are 7 and 187. Here the resulting public keys are 7 and 187. And for the private keys are 23 and 160. Okay. And by using 23 and 187. Okay. And the example shows the use of these keys for an input text of 88. Here I have taken 88. 88 power 7 mod 87. Then it was converted the ciphertext into ciphertext. Now my plain text is 88. Now the plain text was converted into ciphertext, that is 11. Then this was converted by using the decryption algorithm. Here, what is a private key? Our private key is 23. With this, the was converted once again into plain text. Now our plain text is 88. The ciphertext is 11. Okay. And by using our theme, our RSA algorithm, we have done with the plain text waveform. Okay. Now, here this is the theme of the RSA algorithm. Now we'll continue the same topic with what is meant by hashing. What is hashing? Hashing is a mathematical function. A hash function is a mathematical function that takes input or message, and it is going to produce a fixed size string of characters. okay, which is typically a hexadecimal number. And the output is called the hash value or hash code. It is unique to specific input. And what is mean by these hash functions, which are widely used in computer science and cryptography for various purposes, including the data integrity, verification, password storage, and digital signature, all these things. Okay. And now, what are the key characteristics of a good hash function? Okay. Here, the key characteristics of a good hash function are it is deterministic and fixed output size, as well as efficient, okay, and pre-image resistance, collision resistance, and avalanche effect. What is meant by this deterministic? Here, for example, if we have given an input, the hash function must always the same hash value. The deterministic nature ensures consistency in the generated hash values. What is a fixed output size? Regardless of the size of the input, a hash function is going to produce a fixed size output. For example, secure hash algorithm with a 256-bit output always produces a 256-bit hash value. What is meant by this efficient? Hash function should be computationally efficient, enabling quick calculation of the hash value for any input. Next, what is a pre-image resistance? It should be computationally infeasible to reverse the process and determine the original input from the hash value. This property is known as one-wayness. What is collision resistance? It should be computationally infeasible to find two different inputs that produce the same hash value. Avoiding collision is crucial for maintaining the integrity of the data. What is avalanche effect? The small change in the input should result in significantly different hash value. This property ensures that similar inputs do not produce hash values. And P pseudo-randomness. The hash values should appear random and unrelated to the input, even if the input has a major change. This property is mainly useful for the security applications. All the best, everyone. With this, our 5th unit concepts are complete.